In this exercise, we are going to obtain a plane having certain angles with two other given planes. In this case, we are going to have as reference planes or given planes the horizontal plane and the vertical plane, and we want a plane fulfilling the condition of having an angle of 45 with the horizontal plane and an angle of 60 with the vertical plane. So since the angles are known, we're going to start building the first of the cones we need to build. We select the build, insert a new part, and we edit the part. And in this workspace, we are going to draw first the rectangular triangle, which is going to give us afterwards the cone we are looking for to define the angle with one of the planes. So first we draw this rectangular triangle. We make the two legs perpendicular. Yeah, we select them and we set this relation. I'm gonna check that the relation was recorded. No, it wasn't. So we do it again. Yeah, now it's recorded. So now, since we need to account for the angle given, which is 45, we need to set this angle between the hypotenuse and the horizontal leg of the cone. We set this angle to 45. Yeah, so now it's done. And something that is also advisable in this case is to make the size of the rectangular triangle fixed and slightly smaller than the one we have, so the cones we can work with them afterwards in an easy way. So yeah, we are going to write 20 for the horizontal leg. And once defined this rectangular triangle, we exit the addition and we proceed with the revolution. Now the vertical leg is going to be the axis of revolution, and we have obtained the cone of 45 degrees. We are going to save this part. We write the name we want, in this case cone 45, for example. And once that is saved, we will exit the addition of the part, and we will delete the cone, and we will insert it afterwards. So now we are gonna reproduce exactly the same procedure with the second angle. We need to define the angle of 60. So we insert a new part, we edit this part, and in any of the planes of the part, we are gonna draw this rectangular triangle. It's taking its time today, the software. Yeah, so now we select the line tool and we draw the rectangular triangle. We make both legs perpendicular. And now, since the reference of the angle is going to be relative to a plane, we are going to set the 60 degrees angle between the hypotenuse and the horizontal leg. Now it's done. Now, to make both cones more or less of the same size, we will also impose the radius of the base or the horizontal leg of the triangle to be of 20 units of length. Okay. Now we exit the sketch edition. We make the revolution of the second cone. We select the axis of revolution and we proceed with the revolution. So well, now we have the second cone, we save it. We will write cone 60 in this case. And now we exit the part edition and we delete again the second cone. Now we are gonna insert in this blank assembly document these two components or parts we have already created, the two cones. We select them and now we have them on the screen. We can place them here, for example, one besides the other one. The first thing to do now, or we advise you to do, is to change the color of the cones to make it easier to work with them afterwards. We are going to make them transparent and give them a different color. In this case, despite we are not going to superimpose both of them afterwards, but it's always advisable to do this. So we paint the first one with the blue color and now we select the second one. We make it also transparent and we select a different color. Well, so now that we have the two cones color and transparent, what we need to do is we need to place each one on its position. So the first one, the one of 45 degrees, if we remember, we need to orient this first cone with its base parallel or coincident with the horizontal plane. We select the base and the horizontal plane and we will set this relation. Okay, well, I couldn't do it at first because the cone was fixed, was not floating, so we made it floating now. And now we can set this relation between the horizontal plane and the base of the cone, the relation of parallelism or coincidence. We will select the coincidence in this case, but it will be exactly the same. Well, now we do the same with the second one, but in this case, the base of this second cone is coincident with the vertical plane. We are gonna change the view. We will set it to isometric, so we do not lose the reference. Well, so now we select the vertical plane and the base of the cone, and we impose the coincidence relation. Well, we will place the cones close by. And now, since we are trying to look for a line containing a plane and contained on the surface of both cones, and this line is going to define us the plane we are looking for. So the first thing we need to do is we will select the 3D sketch and we will draw a line on each surface of each cone, a generatrix of the cone, and on top of this line we are gonna place a plane. a plane tangent to the surface of the cone and containing this generatrix. So this first plane already fulfills the condition of having 45 degrees with the horizontal plane, and this will be a possible plane among an infinite number of solutions. We are gonna do now the same with the second cone. We drew this generatrix on the surface of the cone. We define this second plane containing this generatrix and tangent to the surface of the cone. And now this plane also fulfills the condition of having 60 degrees with the vertical plane. Since now we are looking for a plane fulfilling both conditions, we set the relation between both planes of parallelism and we get a solution. The resultant plane, which is going to be or planes that are going to be parallel planes or even the same one, are going to be fulfilling both relations. So that will be one of the solutions among the 4 possible of this problem. So we select both planes and we make them parallel. If we would like to obtain another solution, another plane, which also will fulfill to have 45 degrees with the horizontal plane and 60 degrees with the vertical plane, we will draw another 2 generatrix of each one of it on each cone. We will place these lines in a slightly similar direction. We create the planes on top of these 2 generatrix tangent to the cones. Now we are creating this 4th plane on top of the second cone, and now if we set the parallelism condition between these 3rd and 4th planes, we have got now a solution. Okay, we select one, we select the other one, and now we set this relation and we got another solution. We will just redo exactly the same process to obtain the other 2 solutions that are left.